Ever wondered how clouds can affect a solar eclipse? Solar eclipses, these awe-inspiring celestial events, captivate us with their unique interplay of light and shadow. However, our atmospheric conditions play a crucial role in how we experience them. Clear skies, for instance, are vital for optimal viewing. But what happens when clouds roll in? Can they enhance or diminish the spectacle? These are questions that have intrigued astronomers and enthusiasts alike. Today, we're delving into the fascinating interplay between clouds and solar eclipses. A solar eclipse, a cosmic ballet where the moon steals the spotlight from the sun. Picture this. You're on Earth, looking up at the sky. Suddenly, the day turns to twilight and the sun seems to disappear, replaced by a glowing ring or a dark disk. This is a solar eclipse, a natural spectacle that has fascinated humanity for centuries. So what exactly is going on during a solar eclipse? To put it simply, a solar eclipse occurs when the moon passes between the Earth and the sun, casting a shadow on our planet. But not all solar eclipses are the same. There are three main types: total, partial, and annular. During a total solar eclipse, the moon completely covers the sun, leaving only a glowing corona visible. It's a breathtaking sight, as day turns into a strange kind of night. This phenomenon, however, is relatively rare and can only be seen from specific locations on Earth. On the flip side, a partial solar eclipse is when the moon covers only a portion of the sun. Even though the sun isn't completely obscured, it's still quite the spectacle, with the sun appearing as though it's had a bite taken out of it. Lastly, we have the annular solar eclipse. This happens when the moon is at its furthest point from the Earth in its orbit, making it appear smaller in the sky. As a result, it doesn't fully cover the sun, and we're left with a bright, fiery ring, also known as the Ring of Fire. But what role does the moon's shadow play in this cosmic dance? The moon's shadow consists of two parts: the umbra, where the sun is completely blocked, and the penumbra, where only part of the sun is obscured. Depending on where you are in these shadows, you'll experience a different kind of eclipse. So, a perfect alignment results in an awe-inspiring solar eclipse. But what happens when clouds enter the equation? Clouds, the ever-changing decorators of our sky, can be both a blessing and a curse for eclipse watchers. Let's take a moment to appreciate these fluffy, floating phenomena. They're like nature's own theater curtains, setting the stage for the grand spectacle of a solar eclipse. But just like any good theater production, timing and visibility are everything. Imagine this: a thin layer of clouds, almost gauzy in their lightness, stretching across the sky. They're not enough to obscure the sun, but they do something magical. As the eclipse begins, these thin clouds act like a natural filter, enhancing the colors of the eclipse and adding a certain ethereal beauty to the event. They serve to soften the sun's glow, making the dark silhouette of the moon even more pronounced. The result? A breathtaking view of the eclipse that's heightened by the clouds' natural color play. But clouds, as we all know, aren't always so accommodating. Picture now a sky filled with thick, heavy clouds. They hang low and ominous, more like a wool blanket than a gauzy veil. As the moment of the eclipse approaches, instead of enhancing the view, these clouds obscure it. The sun, the moon, the majestic dance of celestial bodies. It all gets lost behind a veil of gray. The eclipse might be happening, but for anyone beneath these clouds, it might as well not be. Clouds can dramatically influence how we experience a solar eclipse. They can be the difference between a breathtaking spectacle and a missed opportunity. They can transform a moment of celestial wonder into a meteorological disappointment. But that's the thing about clouds: they're unpredictable, always shifting, always changing. So how do we make the most of this? How do we ensure that the clouds enhance rather than hinder our eclipse viewing? Is there a way to predict what role the clouds will play during a solar eclipse? Clearly, clouds can dramatically alter our eclipse viewing experience, but how can we predict these conditions? Predicting weather patterns, especially for specific events like an eclipse, is a complex science. It involves a blend of sophisticated technology, keen observation, and a dash of educated guesswork. Meteorologists and the Farmer's Almanac, an annual North American periodical that's been around since the early 19th century, attempt to forecast weather conditions for future eclipses with surprising accuracy. Meteorologists use a combination of satellite imagery, radar technology, atmospheric data, and climate models to paint a picture of what the sky might look like on any given day. On the other hand, the Farmer's Almanac uses a secret formula devised in 1818 that predicts weather patterns up to 2 years in advance. The formula takes into account things like sunspot activity, tidal action, and the position of the planets. Now, let's talk about some places likely to have clear or cloudy skies on the day of an eclipse according to the Farmer's Almanac. The Pacific Northwest, for example, is often predicted to have clear skies, making it a prime location for eclipse viewing. Conversely, the Southeast is known for its humidity and frequent afternoon thunderstorms, making it a less reliable spot. Remember, these are predictions, not guarantees. Weather is a fickle friend and can change at the drop of a hat. So, with a bit of planning and a touch of luck, you can find the best spot to witness the next solar eclipse. Let's circle back to our initial question. How do clouds affect a solar eclipse? We've journeyed through the cosmos, understanding the fascinating phenomenon of solar eclipses. We've explored how the moon, sun, and earth align in a celestial ballet, creating a spectacle that leaves us in awe. Then we delved into the world of weather, specifically the role of clouds. These fluffy formations, while often a joy to watch, can be a double-edged sword during an eclipse. They can either enhance the experience by creating unique light patterns, or hinder it by blocking our view of this celestial dance. We also discussed the importance of weather predictions, especially those provided by the Farmer's Almanac. These forecasts help us determine the best viewing locations for an eclipse, ensuring we have the clearest possible view of this astronomical marvel. Next time a solar eclipse is on the horizon, remember, the clouds overhead could be the difference between an obscured view and a breathtaking spectacle.